Okay, 10 kilograms to 100 kilograms. Next up is a leg of lamb. We already mentioned lamb in the context of beef, so we'll revisit it, and I want to make a few more points. This is at a whopping 38 kilogram CO2 equivalent for a 2 kilogram joint at the checkout when you buy it at the grocery store. For the same carbon footprint as a leg of lamb, you could have a bowl of porridge made with half milk, half water every day for 4 months. So just one leg of lamb is worth everyday porridge for 4 months. Okay, so you can imagine the situation or the footprint that you expect from lamb. And as we already saw this figure before, we are looking at kilogram CO2 equivalent post farm gate emissions, which includes processing, transport, retail, cooking, and waste disposal, and production emissions includes all emissions before the product leaves the farm. So lamb was way up here with most of the costs coming in on-farm production, and beef is actually quite a bit lower, even though it's higher than everybody else. Then we had other dairy products like cheese, milk, and yogurt, and so on. But we also have other meat products, fish products, and so on. What is the point? The point is that if you look at kilogram CO2 equivalent per kilogram of edible meat at farm gate, there are lots of emissions from ruminants like sheep and cattle. So enteric methane emissions from beef and chicken are shown here. So obviously beef is famous, chicken is not a ruminant. Feed production 4.67 and 1.26 kilograms CO2 equivalent for beef and chicken. N2O is much lower for chicken than beef, but still big poultry farms in places like the eastern shore of the Chesapeake Bay can cause quite a bit of pollution in the water and in the bay itself, in the groundwater and the bay. Manure N2O emissions we already mentioned. Transport inputs, manure methane emissions, and on-farm energy use. So here we're not comparing lamb and beef, but we're comparing beef and chicken, and beef is lower than lamb in some of these numbers. Looking at the production emissions from unavoidable waste, so beef production emissions and consumed beef together have 56%, and then you have lots of other things like domestic transport, processing, home cooking, production emissions from avoidable waste, for example, losses at plate and spoilage, that's at 15%. Production emissions from unavoidable waste like moisture loss, fat loss during cooking, and so on, which amounts to 19%. Okay, so these are things you can keep in mind to see if you can do anything about any of these where you control things like cooking waste and other just food waste and so on. When you look at chicken, on the other hand, production emissions of consumed chicken is 34%, processing is 24%, home cooking is 17%, and transport, refrigeration, and waste disposal are down here, with production from avoidable and unavoidable waste adding up to 18%. Okay, so anything that is avoidable waste is where you can also play a role. In general, the production emissions from avoidable waste, production emissions from unavoidable waste, and production emissions at farm gate can be looked at. Here again we are back to lamb. So lamb is still very high in terms of production emissions at farm gate before the before processing, not including waste. So you have avoidable and unavoidable waste being added here, which is again larger than beef. Cheese is down here, farmed salmon, and so on. So lamb, surprisingly, is much more inefficient and higher carbon footprint, and there are many arguments made that it does a lot of things like facilitating additional soil carbon uptake and so on and so forth by grazing on the slopes, etc., but the numbers are not very robust and convincing in that case, because the sheep do wander around and belch out a lot of methane all day, and in general turns out that a leg of lamb is quite carbon intensive. Okay, let's look at carpet. Just another item on the list at 10 to 100 kilogram carbon footprint. 76 kilogram CO2 equivalent if it's a thin polyurethane carpet with thin underlay for a 4 meter by 4 meter piece of carpet. 290 kilogram CO2 equivalent if the same area is covered in thick wool, polypropylene or nylon with generous underlay. So can you choose these things? Sure, you can. If you have a 50 meter squared of top end carpet in your house, that could add up to 900 kilograms of embodied emissions, equivalent to a burger a day for a year. So carpeting is very much a mid-latitude European American thing, and there are many people who prefer wood floors as opposed to carpet, and then maintaining carpet, vacuum cleaning it, removing the stains, washing it, etc., are always a big cost, but people love it. It does provide some aesthetic value, but there you are. So the carbon footprint of different carbon types is listed here. The general: felt underlay, nylon, polyethylene terephthalate, PET, PET, polypropylene, polyurethane, and wool. Carbon footprint in kilogram CO2 equivalent per kilo. For the average is 3.89, and nylon is higher, PET is higher, wool is of course quite high, polyurethane is lower, and kilogram CO2 equivalent per pound is converted here. But there is a company called Interface, which is certified carbon neutral and has just announced that they will go carbon negative in the next decade or two, and their own report says Interface set what may be the highest sustainability benchmark of any industrial company, and they have worked out details of the entire life cycle to reduce their production and everything together to make their end-to-end product net zero as of now, carbon neutral. So shooting for zero, the impact of Interface's own operations. Since 1996, we have renewable energy, increased the total renewable energy used in global manufacturing sites to 89%, including 100% renewable electricity use, 96% lower greenhouse emissions, 69% carpet carbon footprint reduction, 89% less water use. For example, decreased the water used at manufacturing sites by 89%, 99% renewable energy in the US and the EU. So they reached 99% renewably sourced energy in our manufacturing sites in the US and Europe. This is their own report. Reduction in waste to landfall was 92%, and reduction in energy usage was 46%. Here, reduced energy we use to make products by 46%. Obviously, a company that has shown great innovation and consciousness and efforts to stay very high on maintaining their carbon neutrality, and now already they're looking ahead and saying they will go carbon negative in the coming future, which is great. So leg of lamb and carpet, quite a contrast, but again, you know how it works. You make your choices, you keep your preferences in mind, the kind of carpet, the amount of lamb you want to eat, but just be aware of what carbon footprint comes with them. If you are in India, I don't think I've ever seen carpet in any of the houses. I don't know if I've seen any in China either, but China spans from the very warm southern provinces to very cold northern provinces. So it's possible that in the north they have carpets in the house, but nonetheless Africa, I can't imagine, has much carbon. But all these countries, for example, China supplies much of the raw material for making carpets, and the book points out that the energy used and the inefficiencies, source of energy coming from coal, for example, and so on, for the raw material that is being bought by, let's say, the UK and US carpet manufacturers, has lots of embedded carbon in it. So that's something one has to worry about as well, where the raw material comes from, and how large is the carbon footprint of that material at production sites. Remember, we looked at steel, which can vary largely in its carbon footprint depending on where it's produced. The same thing goes for all the raw materials that come in for other products, could be furniture, carpets, cars, trucks, anything you can think of. Okay.